Hello everybody. I would like to introduce you to my talk using the NENGO environment for developing models of speech production and speech perception. My name is Bernd Kröger. I'm the leader of the Neurophonetics group at the Medical Faculty of the RWTH Aachen University, Aachen, Germany, and you can find more information about my work on www.speechtrainer.eu, which means Europe. So the main question I would like to focus on in this talk is how can experimental sciences benefit from models? When I have given a first answer to this question, we will concentrate on the NENGO framework, which enables us to develop brain models. Then I would like to introduce my own work I have done using NENGO. That means I will introduce you to my speech processing model. Processing in this case means speech production and speech perception. Here we will concentrate on the architecture of the modeled brain or of the model, and we will concentrate on some simulations done by using the models. That means we can concentrate on tasks and simulate the behavior of the brain, yes, at least of an avatar, of a modeled test person, in this case. Last but not least, I will give some concluding remarks. How good is the model? So we would like to talk on the realism of the brain models, especially of this model, and how can we benefit concerning our scientific work from the work we have done here using brain models. And this is especially focusing on medical research. Entschuldigung. So, models in general, models do not necessarily lead to new detailed knowledge. That means models are often not capable to answer two specific questions, focusing on quantitative ideas. That means we cannot always answer questions like how strong is a specific effect. But of course we can say this effect exists because of this and that reason. That means models help to understand the basics. That means the functional organization of neural processes of speech production and speech perception. They can answer questions concerning how many interactions exist between different processing stages. That means between the modules or levels of the models. And first of all, in order to understand a process, how needs this process, in this case the brain function, has to be organized in modules or levels. So, and then last but not least, we can answer questions like this or that effect occurs because of this functioning we have seen during the development of the model. So, of course, models can generate new knowledge. For example, concerning the relationship between neural structure and behavior. That means we can use an avatar in which the brain is a part and look how is this avatar behaving. And that means, in consequence, we can see how neural dysfunctions change behavior because the model defines the neural function, and so we can define in detail the neural dysfunction. This helps us in, for example, refining medical screening methods or in developing new screening methods. So, neural models define the structure of the brain That means neurons and the connections between neurons. But what may be more important, they define the neural functioning of the neurons and the functioning of the connections. That means the spiking, the forwarding and spreading of neural activity. Yeah, and that can be summarized as neural processing. So we are able to simulate macroscopic behavior in case of a large-scale brain model if this is embedded in an avatar. And we can give clear definitions for neural dysfunctions because the model, the brain model, gives a clear definition of neural functioning. And thus we can relate neural dysfunctions to a resulting behavior, and thus we can relate neural dysfunction to specific speech disorders, to symptoms of speech disorders. So, in the case of this talk, or in the case of my model, I developed my model using the NENGO framework. NENGO means Neural Engineering Objects, and you can get it from this website here. The software is free, is open source, but really professional developed. I never saw such a professional developed brain model. I tried a lot of them before. It is Python based, so it's running in each operating system and can be embedded in all Python development environments, for example, in Anaconda. And thus we have the benefit that we can use all the math libraries or the plotting libraries. So at least programming with NENGO makes it very comfortable as programming in a MATLAB environment. And not just the NENGO environment is professional from the software aspect and from the software engineering aspect. It is also professional developed from the scientific background. So Professor Chris Eliasmith, leader of the Center of Theoretical Neuroscience at the University of Waterloo in Canada, he developed these models and the background for these NENGO models over years. And this is summarized in his book, How to Build a Brain. So, and last but not least, for this first video, I would give an overview what I will do in the next video. I will go in the details of NENGO, but what does NENGO comprise? So NENGO comprises a basic neuron model or different neuron models for cortical neurons, for subcortical neurons. We are using mainly the simple leaky integrate and fire neuron model. And what is more important, we have neuron models we have in all the approaches for modeling neural structures. But what is specific for the NENGO architecture is that we have really elaborated concepts or strategies for connecting neurons. We will see that the NENGO approach uses concepts like neuron ensembles, neuron buffers, and specific neuron buffers, which are short-term memories. We can directly access associative memories. We can directly control binding buffers and all these things which are important for cognitive neural modeling. So we have strategies for coding higher level items like concepts. This is the S-pointer architecture, which is part of the NENGO concept. But beside this cortical modeling, we have a fully developed model for the neural control processes over time. That means we have a fully developed model for the cortical control loop. That means for the basal ganglia and thalamus complex. And it is not just a model for modeling cognitive problems, but as well a model for including the periphery, so that we really can do tasks like speech production and speech perception. So there are strategies for connecting the periphery and building up a complex avatar where the brain model as a large scale model is just a part. So we can connect sensory input to our brain models in our case. The ears can be modeled, and we can model motor output. In our case, we can model the control on speech articulators. So thank you so far. In the next part of the talk, I will go a step further and go in the details of the NENGO development environment.